In 1978, a 59-story tower stood finished and full of people right in the middle of Manhattan. People worked there every day. And the man who designed it was about to sit down and do a piece of arithmetic he would never forget. In a strong enough wind, this building could fall over, not in some once-a-century hurricane. In an ordinary storm, the kind the city sees all the time, he would soon know that. And almost no one else ever would. This is the Citicorp Center. When it opened in 1977, it was the most modern thing on the skyline. More than 900 feet of silver aluminum with a strange slanted roof cut at a sharp angle across the very top. That slope was meant to hold solar panels. The panels never came, but the shape stuck and it made the building famous. From the street, it looked like the future had landed on Lexington Avenue. What almost nobody stopped to look at was how the thing stood up at all. Because there was a problem down on the ground. A small church sat on the corner of the block, St. Peter's. It had been there for years and it would not sell, not unless the new tower left its corner completely alone. So the engineers did something daring. They lifted the entire tower up into the air and stood it on 4 enormous columns. Not at the corners where you would expect to find them. In the middle of each side. That left the corners of the building hanging out over nothing. About 72 feet of skyscraper, reaching into open air, with the little church tucked safely underneath. It was a brilliant solution. It was also the beginning of the problem. Standing a tower on 4 legs in the middle of each face is not a simple thing to do. To carry all that weight, the building's engineer ran row after row of giant diagonal braces up its sides, like stacked chevrons, funneling the load and the wind down into those 4 great columns. On paper it was elegant, in steel it was beautiful. And it left the whole tower leaning on a single, clever idea, that every one of those braces and every joint that held them together would do exactly what the drawing said. To understand what happened next, you have to understand the man who drew them. William Le Mesurier was not a household name. Among engineers, though, he was close to one. From his office near Boston, he had helped shape some of the boldest structures in the country, the kind of work that won awards and turned heads. The story goes that the idea for this tower's frame, the great diagonal braces that let it stand on 4 legs, first took shape as a rough sketch. On a restaurant napkin, he had built a career solving problems other people called impossible. Which is why, when a small doubt about his most famous building began to grow, he could not let it go. There was one more thing this design needed. A tower this tall and this light wanted to sway in the wind, enough that people near the top would feel it. So Le Mesurier added something brand new. Near the roof, he placed a 400-ton block of concrete floating on a thin film of oil. It was rigged to slide and push back against the building's movement. It was the first device of its kind ever used in an American skyscraper, and it worked. It cut the swaying almost in half. There was just one quiet catch: it ran on electricity. And the design that made this tower famous was the same one that would nearly bring it down. About a year after the building opened, a question arrived at the engineer's office. It came from a student working through the tower's design for a class. The question was simple. What happens when the wind doesn't hit the building square on a face, but catches it on a corner at an angle leaning on 2 sides at once? Engineers have a name for that. They call it a quartering wind. The official answer was that the building was fine. But the question didn't quite go away. So Le Mesurier sat down to run the math himself, expecting, like anyone would, to confirm that everything was exactly as safe as he had promised. Here is what a quartering wind does. When the wind comes straight at a flat face, the braces inside share the load in the careful, balanced way the engineers had planned for. But strike the same tower on its corner, at 45 degrees, and the wind presses on 2 faces at the same instant. For a square building, the city's code never required anyone to test that case. It wasn't an oversight by the rule makers. It was the rule. But when Le Mesurier actually ran the numbers, the force in some of those diagonal braces jumped by about 40%. The building had been certified as safe. It simply hadn't been certified against this. Then he found the second thing. The joints that tied those braces together. The places where all that force had to pass through. He had drawn as welds. Solid, continuous steel, fused into one piece. But somewhere during construction they had been changed. bolted together instead of welded. No, this was not sabotage, and it was not a blunder. Bolting was cheaper, it was faster, and on paper it was completely legal. The kind of substitution that steel fabricators made all the time. The bolts themselves were not the mistake. The mistake was that nobody went back and rechecked them. Because a bolted joint and a welded one do not hold the same way under the same wind. This is where his two discoveries met. Put a quartering wind on the tower, and the load piling into those bolted joints didn't climb by 40%. At the worst of them, a single joint down on the 30th floor, it climbed closer to 160%. A welded joint might have swallowed that. A bolted one had far less to give. He checked it, and then he checked it again, hoping to find the error in his own work. There wasn't one. The comfortable margin of safety he thought he had built in, the cushion that every tall building is supposed to carry, wasn't thin. It was gone. So he did the calculation no engineer ever wants to do. He worked out how strong a storm it would take to start tearing those joints apart. With the big damper running up top, steadying the sway, the answer was a storm so rare you might see it once in 55 years. Survivable, barely. But remember the catch, the damper runs on electricity, and in a serious storm the power goes out. With the damper dead, the number changed completely. Now a storm strong enough to bring the building down was a 1 in 16 chance. Every single year, that is not a freak accident waiting to happen. That is a coin flipped once a year that sooner or later comes up wrong. Picture for a moment what that number actually meant. This was not a crack in a parking garage. This was 59 stories, standing over one of the most crowded patches of ground on Earth, held up on 4 legs, and a set of joints that the wind could overload. If the worst storm came on the worst day, the failure wouldn't stay polite. And the trigger wasn't sabotage or an earthquake or some 1,000-year freak. The trigger was ordinary weather. A strong gusty day hitting the building from exactly the wrong direction. Le Mesurier was now the only person who fully understood that, sitting alone with a stack of calculations and a building full of people who had no idea. So consider the position he was in. It was the middle of summer. The building was full, thousands of people coming to work inside it every day. Taking down a finished skyscraper quietly was impossible. So was emptying the middle of Manhattan without telling the whole world exactly why. He had 2 roads in front of him. Stay silent, hope the weather stayed kind, and gamble with a city full of people. Or walk into the offices of the bank, the architect, and the lawyers, the very people who could end his career in a single afternoon, and tell them what he had found. He told them, all of them. He laid out the flaw and the fix and the risk in plain language. And within days, a quiet emergency was running underneath one of the busiest towers in New York. Saying yes to the fix was only the beginning. To pull it off in secret took a small army of the right people. A second engineer, Leslie Robertson, was brought in to check the work and to watch the building from the outside. Strain gauges were fixed to the steel and read in real time, so the smallest dangerous flex would show up the instant it happened. A wind expert was consulted on exactly how violent a storm could get and how fast. Lawyers and insurers were quietly folded in. For the first time, the handful of people who could see the whole picture were in one room, and sworn to keep it there. While that quiet machine ran indoors, the city itself got ready for the worst. A plan was drawn up for the thing nobody wanted to say out loud, an evacuation. If a dangerous storm arrived before the welding was done, a 10-block circle around the tower would be cleared. Somewhere between 1,200 and 2,000 Red Cross volunteers were placed on standby. 3 separate weather services were hired to watch the sky, independently, so that no single forecast could ever be wrong alone. Everything was in place, everything except good weather. Then the real work began, at night. Every evening, after the offices emptied and the lights came down, a second shift arrived. Carpenters first, raising plywood walls around the bare steel. Then welders, climbing inside the skeleton of the building, torches lit, working in the dark. Joint by joint, floor by floor, they laid thick steel plates over the weak connections and welded them down into something solid. More than 200 of them. The work ran until 4 in the morning, 7 nights a week, all through the late summer and into the fall. It was one of the largest secret repairs ever attempted on an occupied building. And every morning it disappeared, the plywood came down. The dust was swept away. The office workers rode the elevators back up to their desks, typing, calling, filing, eating lunch on the plaza, with no idea that the building around them had been quietly rebuilt overnight. They were never told. To them, nothing was happening at all. That gap, calm by day, urgent by night, is one of the strangest things in this story. A skyscraper saved in shifts in the dark, while the people it was saved for lived their ordinary lives inside it. And then, with the repairs only half finished, the sky began to turn. A hurricane named Ella spun up out in the Atlantic and started to climb the coast, and for a few long days it threatened the whole eastern seaboard. This was the exact thing they had been dreading. They tracked it for days, watching the gauges, ready to clear the streets at a word. Then Ella did them a quiet favor. She stalled out over open water, well off the Carolinas, turned back toward the northeast, and wandered away to sea. She never reached New York. The building got its reprieve, and the welders bent back over the steel. There is one last piece of luck in this story, and it is a strange one. That same stretch of weeks, nearly every major newspaper in New York went on strike. For almost 3 months, the big presses sat silent. The largest structural emergency in the city's history was unfolding, floor by floor, in secret, and the papers that would have run it across every front page could not print a single word. By October, the last plate was welded into place. The tower that had been, by its own engineer's math, a coin flip away from disaster, could now stand through a storm you might expect to see once in 700 years. The people who worked inside it never felt a thing. What is almost harder to believe than the flaw is how completely it vanished. No public inquiry was ever held. No charges, no headlines, no plaque on the wall. The tenants kept coming to work, floor by floor, with no idea what had happened in the dark above and below them. And the one moment a story might have broken into the open had been swallowed whole by that newspaper strike. So it simply sat there, an open secret among a small circle of people for 17 years. It surfaced almost by accident. A writer heard the tale at a party and pulled the thread. In 1995, a magazine finally told the world what had happened in the summer of 1978. When it finally came out, the real surprise wasn't a flaw. Every building has flaws. The surprise was the man. Le Mesurier could have stayed quiet, protected his name, and let the whole thing fade into nothing. Instead, the moment he understood the danger, he picked up the phone and reported his own mistake. He told his client, he told the city, he told the very people who could have ended his career in an afternoon. Today, that choice is taught in engineering schools, held up as the example of an engineer who turned himself in. And yet, here is the part that almost never makes it into the story. In the years since, other engineers have gone back over those very same numbers, this time with wind tunnels and tools that Le Mesurier never had. What they found is unsettling in a completely different way. For a square tower like this one, they concluded, it is the straight-on winds that truly govern a design. The ordinary kind Le Mesurier had used all along. The quartering winds that caused all the fear may never have been the real threat. The original alarm, the reassessment argues, leaned on an assumption that quietly overstated the danger. Le Mesurier had, in fact, weighed those angled winds in his first design, and he had met the code. Some now believe the famous one in 16 was never really that close. That the secret repair, welded in over all of those long nights, may not have been needed at all. We may never truly know how near the edge it actually came. But maybe that is the more unsettling thought of the two, because whether the danger was real or only believed, one thing about this story does not change. It began with a single question, asked almost by accident, by a student so far outside the project that, to this day, no one is even quite sure which one it was. And that was enough. Enough to make the engineer of a finished, certified, fully occupied skyscraper take it quietly apart in the dark, just to be sure. He got his second chance to check his own work. Most engineers never get that, and most buildings never invite it. So it is worth sitting with one last question, the next time you walk past some tower you have never thought twice about. How many of the buildings standing around you right now were simply never asked the right thing?